Sometimes as crystals form, water molecules will actually get trapped in the crystalline matrix of that compound. Or simply because of attractive forces, they simply adhere to those formula units of that compound. So the water molecules essentially become part of that crystal. We call these water molecules waters of hydration. And those solid compounds, ionic compounds that have those water molecules trapped inside them are called hydrates. A hydrate is a compound that has a specific number of water molecules bound to its atoms, to each formula unit. Here are a couple of examples. The first one is copper 2 sulfate, but in this form of copper sulfate, every formula unit has 5 water molecules bound to that formula unit. Here's another one, sodium carbonate, and in this case, every formula unit has 10 water molecules bound to it. So you might wonder how we name these. It's actually pretty simple. We use the name of the compound, a prefix, and the word hydrate. The prefixes we use are the ones we've used previously. Mono, di, tri, tetra, penta. This is copper 2 sulfate pentahydrate. This one is sodium carbonate decahydrate. You see how it works? It is possible, though, to heat a hydrate and drive away those waters of hydration. We are left with what we call an anhydrous compound without water. But say that we have a sample of a hydrate, we just don't know what the formula is. In this case, we have an iron 2 chloride hydrate, but we don't know how many water molecules are attached to each formula unit. In other words, we need to figure out the coefficient X. We would start by heating the hydrate. Let's say that when we heat this hydrate, the 2-gram sample of iron 2 chloride, we are left with 1.27 grams of anhydrous iron 2 chloride without any water. How do we know how much water there is? Very simple. All we do is subtract our anhydrous amount from the original amount, leaving us with 0.73 grams of water. Now we use the steps that we used in our last video. The next step being we find the number of moles of each of the compounds in this hydrate. So we use the molar masses of each of these compounds. The molar mass of anhydrous iron 2 chloride is 127 grams. The molar mass of water is 18 grams. And remember, you calculate molar mass by using the masses on the periodic table. Arranging it in this fashion allows me to cancel the gram units and leave me with mole units. After the calculations, I find that I have 0.01 moles of FeCl2 and 0.041 moles of water. The next step is to take the smallest mole amount and divide all of them by that amount. That means for every formula unit of FeCl2, I have 4 molecules of water. Therefore, my coefficient is a 4. That makes this iron 2 chloride tetrahydrate. Incidentally, you probably run into the anhydrous form of compounds every day. A lot of them are used as desiccants. A desiccant is a drying agent. They're used in all types of products to make sure that water doesn't somehow spoil that product. The new shoes you buy, a handbag, or even beef jerky. They all use desiccants in the packaging because the desiccant will attract the water and keep the water away from that product that you're buying. Here's a problem for you to do for homework. We have a sample of hydrated calcium sulfate. Let's say you start out with 4.89 grams of that hydrate. After heating it, you have 3.87 grams of anhydrous calcium sulfate. Determine the formula for this hydrate and see if you can name it. You can put your answers on the LMS. That's all the time we have for today. Today we learned all about hydrates, how you can have waters of hydration that attach themselves to the crystalline matrix of an ionic compound. We discussed how to name hydrated compounds, and then we showed how you can determine the formula of a hydrate based on its mass before and after heating. Don't look now, but you've wrapped up another chapter. That's the end of chapter 10. You guys are doing amazing. Great job. In our next chapter, we'll talk about something called stoichiometry. Stoichiometry can help us to make predictions regarding the reactions that we see in chemistry. As always, if you need any help with these concepts, please let me know. I'm happy to assist you. Until next time, God bless.